Imagine a dark, heavy rock pulled from deep underground. At first, it looks ordinary, rough, dusty, and almost worthless. But hidden inside that rock is one of the most powerful materials humanity has ever discovered: uranium. Uranium can help produce electricity for millions of homes. It can power nuclear plants, support medicine, science, and even space technology. But in the wrong hands, it can also become one of the most dangerous materials on Earth. The problem is that natural uranium is not ready to become nuclear fuel by itself. Inside natural uranium, there are different types of atoms, called isotopes. The most important one for nuclear power is uranium-235. This isotope can release energy through a chain reaction, producing an enormous amount of heat. But uranium-235 is rare. Most natural uranium is uranium-238, which does not work the same way inside a standard nuclear reactor.
So before uranium can become fuel, it must go through a complex and tightly controlled process called enrichment. The journey begins with uranium ore. It is mined from the ground, crushed, and processed until uranium is separated from ordinary rock. This creates a concentrated material often called yellowcake. But yellowcake is still not nuclear fuel. Next, the uranium is chemically converted into a form that can be used for isotope separation. This step is necessary because uranium-235 and uranium-238 are almost chemically identical. You cannot separate them like sand and stones. The only useful difference is their mass. Uranium-235 is slightly lighter than uranium-238, and the entire enrichment process is built around that tiny difference. Today, enrichment is usually done with centrifuges. These are tall, narrow machines that spin at extremely high speeds. Inside them, uranium material in gas form rotates so fast that the heavier particles move slightly outward, while the lighter particles stay a little closer to the center. But the difference is incredibly small. One centrifuge is not enough. Enrichment facilities use many centrifuges connected together in long chains. The material passes through them again and again, slowly increasing the amount of uranium-235. For nuclear power plants, uranium is enriched only to a low level. That is enough for a reactor to produce heat safely and steadily. The heat turns water into steam, the steam spins a turbine, and the turbine generates electricity. But this is why uranium enrichment is watched so closely around the world. The same scientific principle that can light cities can also become dangerous if pushed too far. Enriched uranium is not just fuel. It is a symbol of how far humanity has gone in understanding nature and how careful we must be when using that knowledge.